So I've already alluded to this idea of isotopes. Isotopes are basically the same element, different isotopic forms of the same element. And if they are the same element, then they must have the same number of protons. And we said number of protons is the atomic number, and that is the symbol Z. I'm kind of saying this for my own good. Okay? So if they actually make them an isotope, they're going to have different masses. They will have different mass numbers. And mass numbers is then the symbol A. Mass numbers is the symbol A. And remember, that is the number of protons, which is the same if it's the same element, atoms are the same element, plus the number of neutrons, which will vary. That's exactly the idea of isotopes. Okay, since they have different number of neutrons, we're going to talk about masses coming up, but the atoms will weigh differently. They will have different, what we call atomic masses. The mass number will be different, and the atomic masses, they will literally weigh differently. Isotopes of the same element. I just think that is so cool. All right. So and this is kind of a physics of the atom. Some conditions are favored, some nuclei are favored where there's only what we call one isotopic form. There's not kind of a different assortment of neutrons that will be stable in that nucleus. But sometimes let's see if I have this coming up. Okay. These actually occur only in one isotopic form. You don't have to memorize these, that would be silly. These actually have two isotopic forms that naturally occur, okay? And then these have three or more isotopic forms that occur in nature. And I'm trying to think how I want to show you this. I might show you in lab, but there's like sheets out there to actually show you an element and show you the isotopes that naturally occur for that element. Well, I guess we'll kind of look at some data coming up. So if you have an element and you want to show one particular isotopic form, all you need to do is give the unique mass number for that isotope. You don't have to give the atomic number because that kind of goes without saying. Okay, because the atomic number is going to be constant. So for instance, carbon, its atomic number 6. It has 6 protons in the nucleus. We have at least 2, if not 3, naturally occurring isotopic forms of carbon. One of them is what we call carbon-12. Okay, so carbon-12, you kind of say it this way, means that the 12 is the mass number. That is A. That's the mass number. It's the number of protons plus the number of neutrons. So check this out. If we know, since it's carbon, it's got to have 6 protons, okay, plus question mark neutrons is equal to 12. What is that question mark? Well, that question mark is 6. So this particular form of carbon has 6 neutrons. Anyway, so you only have to say what its mass number is in order to say which isotopic form it is. So you can spell it out like that. You can do the symbol C-12. You can go ahead, these are kind of similar. Notice what we do is we have the elemental symbol for carbon, C, and then on the left over here, we go ahead and we can either put just in the upper left-hand corner the mass number, or we can put the mass number in the lower left-hand corner, put the atomic number. So this, do you see where this is actually optional? Okay. So these are 4 different ways of basically saying carbon-12. Okay. Let's take a look at, generically speaking then, I kind of like the last designation where you have the symbol for the element, and the upper left-hand corner you go ahead and put the mass number. And then in the lower left-hand corner, you go ahead and, kind of redundant, you go ahead and put the atomic number, number of protons. Okay, so that is kind of a nice way to ball it up. In fact, that's very common. So let's look at an example for fluorine. Switching from carbon to fluorine. This is what, fluorine 19? Okay, where the mass number is 19 and the atomic number is 9. But again, this is kind of redundant. You could actually know that it's 9 is the atomic number because it's fluorine. So on your Unit 2 exam, I'll go ahead and tell you that you're going to run into something just very much like this. So if I were to ask you what is the atomic number, you would say 9. Very good. What is the mass number? 19. Yep, upper left-hand corner. How many protons does it have? It has 9 protons because that's its atomic number because it's fluorine. If it's neutral, and it doesn't say this, but if it's neutral, how many electrons does it have? It also has 9 electrons if it's neutral, equal to the number of protons it has. All right, how many neutrons does it have? Well, we can get to neutrons by taking the mass number, which is protons plus neutrons, and subtracting the number of protons. So 19 minus 9 is 10. Very good. This is just kind of a picture to show you boron. 2 isotopic forms of boron. We have boron 10 on the left and boron 11 on the right. So boron has 5 protons. So again, if we want to go ahead and calculate neutrons, all we got to do is take the 10 minus 5, okay, to give us the number of neutrons in boron 5. In boron 11, we take 11 minus 5 and get 6 neutrons. Hope that works for you. So an important announcement here, important, but I think your slides that you purchased from the bookstore already reflect this. But you're going to want to make sure you do the right problems here. Okay.